Welcome to Learning Intention Lesson or Aim number 11 to investigate, translate, and identify algebraic expressions. Shit. I'm in shit. All right. So we have the success criteria, which is what you're supposed to be able to do at the end of the lesson, which is I can interpret expressions that that represent a quantity in terms of its context. I can translate algebraic expressions in from English to algebra. All right, cool. I don't know where this in came from, but anyways. So we got the standards, and basically I'm not gonna be reading everything. Yeah, my son is going crazy. All right, so mini lesson. Critical thinking, essential question, depth of knowledge, level 3. So it says, draw a valid argument as to why 2x plus y is called an algebraic expression. So I will write the following. I'm not going to write it. I'm just going to tell you what it is so you could write it on your own. Well, based on research, okay, you see, research. Based on research, you could say Google, Yahoo, whatever. Okay, but based on research, 2x plus y, it's called an algebraic expression because an algebraic expression is composed of variables, okay, variables and numbers and coefficients and exponents. So let's see if it's true. 2 is a coefficient of x. 2 determines how many times x is going to be, how much, or the increment that x is going to take. So this is twice the amount of x. Whatever x is, this coefficient is going to double it because 2 times x. If x is 6, then it's going to be 2 times 6. Okay? Does it make sense? Hopefully it does. All right. So that's why this is. Oh, by the way, also contains exponents, you see that? And it contains variables. So that's why it's an algebraic expression. Can I create other algebraic expressions? Yes. Now, what is the difference between an algebraic expression and an equation? Well, an equation has an equal sign. Get it? So the equation has an equal sign, the algebraic expression doesn't. All right. Let's move on. So, parts of an algebraic expression. See that? Coefficient, variable, and a constant operation. I mean, the constant doesn't always have to be there, but it's part of it. The idea is that you're going to have variables, numbers, exponents, but you're not going to have an equal sign. Got it? And, FYI, you could just read the rest, okay? See this? The word term refers to the values that are added or subtracted. 7n minus 2 has 2 terms, 1 and 2. Wow, Becker, really? Sorry, you know what? You're trying to come at me? Boom, I got you. All right. The word factors refers to the values that are multiplied. The term 7n has 2 factors, 7 and n. Duh. It's like having the number 12. The number 12 has 2 factors. Well, not really 2, but it has more. 6 and 2, 4 and 3, 12 and 1. So that's what they mean by factors. Factors are 2 numbers that multiply, give you your desired number. All right. Let's move on to the real deal. All right. I really don't want to spend too much time on this. You could read this on your own. Basically, these are like a sampling of words that are used to represent mathematical operations. So you have, for example, to add, you have add, sum, increase by, more than, exceeds, total, plus, in all, gain, deposit. Add, sum, increase by, more than, exceeds, total, plus, in all, gain, deposit. Okay, that really sounds corny, but anyways. So that's for addition. For subtraction, you also have this little one. You know what? Let's just make it bigger. Okay, cool. Now you can read it. So you have subtract, difference. Anyways, any of these words that you see will represent subtraction. Next, multiplication. Look, multiply, product of. The word of also means multiplication. Times, I'm not even going to mention it. Double, yes, 2 times, right? Triple, 3 times. Twice, 2 times. Oh my God, Becca, use the cheese, use the cheese. Okay, that's not funny. The computer's going crazy. And to divide. Anyways, so you have these little words, okay? And you are going to have to write them down. So, and if you're going to have to write them 100 times each, so you remember what they mean, that's fine. Divide, quotient, per, like 100 miles per hour. 200 miles per 2 hours means 100 miles per 1 hour. Because 200 over 2 is 100 over 1. Divided equally, split into fraction, ratio of. So those mean division. Anyways, so let's get to the real deal, okay? Jesus Christ, how long is this gonna take? So for example here, so it says, remember that variables can be represented by any letter or symbol unless otherwise directed by your doctor. No, not really. Let's try the verbal statement. 5 okay, you know what? That's getting annoying. 5 increase 5. You see that? Increased by 4 times a number. By 4 times a number. I don't know what the number is, so I am going to put a variable. Wow, it rhymes so good, right? So 5 increased by 4 times a number. Increase, that means you're going left to right. Next one. 8 less than twice a number. You see, whenever you hear the word less than, more than, and please mark my words, okay? I'm not playing with you. Whenever you hear the words less than or more than, you have to go from right to left. 8 less than means a minus sign. Less than twice a number. 2 times x. Twice a number. Okay? 2 times a number. I could write parentheses if I wanted to, but I'm trying to let go of this scaffold and go into 4 times x is 4x. So then twice a number should be 2 times x. 3 times a number increased by 9. Increase, that means that you could just follow the regular order. So 3 times a number. 3 times a number. By the way, it doesn't have to be x. It could be n. It could be whatever. So 3 times a number increased by, that means that this number is going to get bigger by 9 units. See that? Let's try this. The product of 4, see that, comma, and a number decreased by 7. The product of 4. The product of 4 means multiplication of 4 and another number. Another number. And a number decreased by 7. Remember what parenthesis means. Dylan, you're sounding like a crazy hyena. Can you stop laughing like that? I know you get excited playing the game, but it's kind of late and I'm trying to record this lesson. Thank you very much. So the product of 4 and a number decreased by 7. A number, you want to put x? No. You want to put n? Okay, fine. A number decreased by 7. Whatever the number is going to get decreased by 7. This doesn't come automatically, guys. You have to practice this. Okay. The number of feet in x yards. The number of feet. First of all, I need to know how many feet in 1 yard. Well, there are 3 feet in each yard. Oh, you should have said that. So the number of feet in x yard. there are 3 feet in any given yard. Oh my God, que estúpido, of course, claro. The number of feet in X yard, there are 3 feet in each yard. So the number of feet, 3. So if X is 1 yard, then this is 3 feet. If X is 2 yards, 3 times 2 is 6. So that's 6 feet. Oh, I'm amazing. All right. Now, express the width of a rectangle which is 7 less than its length. Okay, the width of the rectangle is 7 less than its length. How in the world am I going to represent that? Wait, hold on a second. I remember saying something about the word less than. If you have less than or more than, you're going from right to left. So the width is 7 less than its length. 7 less than its length. You could put capital L if you want to. I really don't care how. Now, of course, you got the answer right here. A number repeated as a factor of 3 times. A number repeated as a factor of 3. As a factor 3 times. The same number repeated as a factor. If the same number is going to be a factor, guess what? Factors of, let's say, 36 are 6 and 6. Okay? So this factor is repeated 2 times, but here it says 3 times. So then you have n equals n to the 3rd power. Beautiful. Let's move on. Oh my God. We're still doing the same thing. That's not a problem. Okay. So let's see what's next. A monomial. What is a monomial? Alright, so from now on, I'm going to make it larger so you could see better, and I'm going to have to move the paper. Okay, I think that's it. Okay, a monomial. A monomial is the product of non-negative integer powers of variables. It has one term. Mono implies one. What do you mean? Well, let's see. For example, negative 3n is a monomial. It has, you know what? A monomial is just one term. 2x, 13p. And you know what? Funny thing is that, okay, sorry, 3n, 2x, 13p. And you know what? What if I had 4x, y, z? What if I had that? Is that one number or 2 numbers or 3 numbers or 4 numbers? Well, there is nothing separating this term. So this is just one number. If there was a plus sign or a minus sign, then it would be a different story. Alright, let's talk about the binomial. Binomial, look, the sum of 2 monomials. Duh! So then, it has 2 unlike terms. Bi means 2. Okay, so how can I do this? Easy. How about negative 3n plus 2x? That's a binomial. Also, you have, okay, let me put this in parentheses. Also, you have x minus 5. That's a binomial. 1 term, 2 terms. It says separated by either a sum or a subtraction. I know subtraction is the new sum, the sum is the new subtraction, whatever. But if it's divided by plus or minus, then it's a binomial. If it has 2 terms. Trinomial. So please read what a trinomial is. Okay, now that you read it, let's give an example. So the sum of 3 monomials. I don't know. Let's try 4x squared plus, I don't know, 2x, no, 4x, I'm going to keep the same number, plus 4x plus 4. I know this really doesn't matter, it's irrelevant. This could have been a 5, a 3, and a 7. It doesn't matter. The thing is that it is a trinomial because it is separated by pluses or minuses. You see that? The operation plus or minus, addition, subtraction, whatever you want to call it, that's what separates them. Got it? So 1, 2, 3. Okay. And a polynomial is anything that is greater than, that has more terms than a monomial. So for example, a polynomial could be a binomial, it could be a trinomial, or it could be a expression that has OD terms, like for example 6y x to the second plus 2n plus 5x plus 6 p, and so on and so forth. That's what a polynomial is. See that? Okay, cool then. Is there anything else to this? Well, let's see. Alright, so algebraic expressions. Let me make this smaller now because we need to read the whole thing. Oh, okay. Alright, so algebraic expressions, unlike expressions, algebraic equations contain an equal sign. I said it before. The difference between an algebraic expression and an algebraic equation is that they have the equal sign. Alright? So we're good? Alright. Now, how do you know there will be an equal sign? You will hear words like is, are, was, where, equivalent to, same as, yields, gives. So basically that's what it is. Alright, now you may want to read this part, so I'm not gonna read it, you read it yourself. Okay. Gucci? Yes, we're Gucci. And now, vamos a ver qué es lo que sigue. Oh my God, I'm gonna have to do these videos in Spanish as well, right? Well, just give me some time. Okay, here we go. I'm going blind, but it's okay. Alright, so verbal statements. 3 times a number divided by 10 equals 15. What? Okay, let's see if I understand. 3 times a number divided by 10. 3 times a number divided by 10 equals 15. 3 times a number, it could be x, it could be y, whatever, divided by 10 equals 15. My friends, welcome to algebraic equations. Oh my God, I haven't done something. You know what I'm gonna do, right? Caught you. Okay. 10 less than the quotient of a number and 2 is 0. So let's see. 10 less than. Remember what this word less than and more than mean. 10. You see, I'm working backwards. 10 less than the quotient. Quotient means what? Yes, exactly. Division. So of a number and 2. 10 less than a quotient, the quotient of a number and 2 is, remember what the word is means? Equals 0. Now you could write this backwards. You could write this and then equals 0. It really doesn't matter how you put it. Okay. Then I gave you the answer to one of the most difficult ones. Let me see if I can make it bigger. Oops, too big, too big, too big, too big, too big. Come on, come on. Okay, right, got it. All right. Represent the cost of access. Okay. Represent the cost of access to a movie website which charges a $5 fee for the first month and then $28 a month for continued access after the first month. Numerical example. For 4 months, the cost will be what? Well, let's see. Remember what it says here. It charges a fee for the first month. That fee is not gonna be accompanied by any variable. It's just a one-time fee, okay, for the first month. But then it charges $28 a month. So I would say 28M, yeah, that would great, for continued access after the first month. So how would I go about writing my equation? Well, let's make this a little bigger. So let's see. C is gonna be equal to the cost. M is gonna be the months. And now look at the equation. It's a $5 fee for the first month. Then after that is $28 a month. Wait, hold on a second. So what is this 28 times n minus 1? I really don't understand, unless you're a genius. Well, think about it. If m, let's say m is 0, right? 0 months. In 0 months, this actually doesn't make any sense. Because if m is 0, at 0 months, you are not paying anything. But then again, watch this. Let's try 0 months. Let's say you're not subscribed, which of course doesn't make any sense. If m is 0, then this is going to be -1. That means that you're going to end up with 28 times -1 is -28. So 5 minus 28, that's going to be -23. You're not going to get $23 back just because you never subscribed. No, you have to be subscribed in order for this equation to work. So let's see. For the first month, you are only paying the $5 fee. So then when m is 1, and let me erase this. When m is 1, this becomes 0, correct? 1 minus 1 is 0. So then you end up with the $5 fee plus $0 that you have to pay monthly. Now, when you go into the second month, okay, you're no longer paying just the $5 fee. Now you are paying for $28 a month for continued access for the first month. So then, when m turns into the second month, okay, now you're gonna have your $5 fee that they charge you on the first month plus whatever comes out of here, okay? So for example, let me explain this in a better way. So the cost is $5 plus $28, and let's say m minus 1, right? M minus 1. Now you are on the second month. You are on the second month, so m is 2. Now 2 minus 1 is 1. So 28 times 1 is 28. So that means that on the second month, you would have paid, oops, oh no. Yes, you would have paid 30 what? $33. Yeah. So on the second month, you start paying you pay $33. On the third month, and basically you just have to plug in the information here and you will understand how it goes by months. I hope you understood that. If you have any questions, you can ask me and I'll be more than happy to explain to you. Alright, so the next one. If chocolate donuts cost $1.10 and chocolate chips muffin cost $2.25, how many of each can you purchase for $20? So here you have to write the equation. Well, let's go for the equation first. Remember what it says. If chocolate donuts, I hate that word, donuts cost $1.10, okay, and chocolate chips muffins cost $2.25, how many of each can you purchase for $20? Not a problem. So look, D is going to be the donuts, M is going to be the muffins. You always try to choose variables that represent your product. You don't want to be choosing X for donuts, although you can, of course. So let's see now. $1.50 for the donuts. Okay. And $2.25 for the muffins. So there is a mistake right here because this one says the chocolate donuts cost $1.10 and now we have $1.50. So it doesn't make any sense. So let us change this to $1.10. Oh my God, it's so easy. Okay, so it's $1.10 for the donuts and $2.25 for the muffins. So whatever the amount is for the donuts and the muffins, remember what is the maximum amount of money that you can spend. You only got $20. So donuts plus muffin should not exceed the $20. We know how much, they cannot exceed $20. As simple as that. Got it? So then it says, numerical example, the cost of 3 donuts and 2 muffins will be what? Well, why does it say $1.50 here? You see, I'm getting crazy with this. At the beginning it says $1.10, so we're gonna keep it as $1.10. I don't know if the typo was $1.10 or $1.50, but it doesn't matter. So the donuts and 2 muffins. So we have 3 donuts at $1.10 and we have 2 muffins at $2.25. Whatever this is, okay, it cannot exceed the $20 that you have. So 3 donuts will cost you $3.30 and 2 muffins will cost you $5. So then you'll get some change back, right? Cool then. Man, this is becoming more difficult than I thought. Hopefully you understand. Okay, so the next question is the following. It says, express the area of a rectangle whose length is twice its width decreased by 6. I have no idea what that means. What do I know? The area of a rectangle is length times width, correct? L times W. Okay. Now, it says the length is twice its width decreased by 6. The length is twice its width decreased by 6. You see, it doesn't say anything like twice the length less than. Remember, if it's less than or more than, the word less than and the word more than means that you're gonna have to write from right to left. But if it just says increase or decrease, you start from left to right. You have to understand that. You have to memorize that. There's no other way around it. All right, so this is what the length is. Twice the width decreased by 6. So now, how do I represent length times width? Well, area is equal to length. What is length? Length is 2W plus minus 6, right? That is the length times the width. You see that? And now this turns into the distributive. Now you want to read it. If you want to write it in a better way or something that makes more sense to you, you could put this W over here. You can always do that. See that? Maybe like that is better. So when you use the distributive property, it becomes easier. Okay. Oof. Independent practice activity number 11. All right. So what does it say? Am I good? Okay. Which value in the expression x 8x minus 12 is referred to as a coefficient? Okay, really, I don't have time for this. We know what the coefficient is. Coefficient is the number multiplying the variable. Oh, okay, what else? How many terms are contained in the expression? One, two, three. Remember, the expression is separated by the plus or minuses. Constant. Common factor. Hello. Common factor is usually what they have in common. So what is it? Your bill at the Fashion Palace can be expressed as C equals T plus 0.08 T. What could 0.08 T represent? Okay, so your bill is your total, whatever you spend, plus the tax on what you spend, right? So, Jordan, I need you, boo. I gotta see you, boo. Okay, I'm getting tired of this, but let's see now. Okay. An S-ounce shot of vanilla flavoring is added to a C-ounce cup of coffee. Okay, now it's getting really complicated. Which choice is an expression representing the concentration of vanilla in the mixture of coffee and vanilla? What the hell? All right. S-ounce shot of vanilla flavoring is added to the C cup of coffee. Okay. Which choice is an expression representing the concentration of vanilla in the mixture of coffee and vanilla? Oh my god, okay. I have to think about this. An S. Okay, my son is not. Dylan, can you be quiet? An S-ounce shot of vanilla flavoring is added to the C-ounce cup of coffee. Oh, okay, vanilla is added to coffee. Okay, good. So let's see. Vanilla plus coffee. I don't think so. Which choice is an expression representing the concentration of vanilla in the mixture of coffee and vanilla? In the mixture, okay? So basically, I need the vanilla, just the vanilla. So it could be either this one or this one. So vanilla in the mix of coffee and vanilla. Is this vanilla in the mix of coffee and vanilla? No, this is the vanilla in the mix of coffee. No. Coffee in the mix of, no. Vanilla in the mix of, oh yes. Of coffee and vanilla, nice. Okay. Let's see now. Whew. During a picnic, Jamal used 2 pitchers to bring soda to the picnickers. The larger pitcher holds X quarts of soda and the smaller pitcher holds Y quarts of soda. Okay, so we're talking about soda. The larger pitcher is refilled with 8 times, okay, 8 times, and the smaller pitcher is refilled with B times during the picnic. Wow, we really have to understand these problems in order to actually answer it, right? Well, how much oh yeah, definitely it's not this one. Because one holds X quarts of soda and the other one holds Y quarts of soda. We're not looking at how many times they were refilled. We're talking about just how much they hold. Well, they hold X plus Y. Ha! Yes. All right, the number of times the pitchers were refilled. Oh, it's telling me, so then this is not the answer. The answer is actually A plus B. Okay? We're talking about the number of times pitchers were refilled, so it's just A and B. Okay. Oh my God, this is... But anyway, you're helping me, so hopefully this is good. The total number of quarts of soda used for the picnic. Well, it depends how many times they were refilled, so... Okay, let's do the next one. So basically we have, let's see now. Number of quarts is, okay, whatever. The number of pints of soda held by the two pitchers, the small and the big one. Well, pints, how many pints? Well, I don't know. Let's see. 2 quarts. No, sorry. 1 quart equals 2 pints. Okay, so 1 quart equals 2 pints. So basically the amount of soda held by the two pitchers should be twice as much. So then let's see. Okay, this is just the number of times they were refilled. Okay, this is what they can hold, the sum of the pitches. And we have this one is basically the total number of quarts used for the picnic. So that leaves me with, oh, there you go, the number of pints of soda held by the two pitchers. Well, if the soda held by the two pitchers is let me see, not for the picnic but for the pitcher, the number of times pitcher will refill. Okay, look at this, look at the top one. The sum of the number of quarts of soda held by the two pitchers. The sum of the number of quarts. Okay, so that would be what? That would be x plus y, correct? Let me see. Just want to make sure I am doing what I'm doing correctly. Let me just check. Yep, I'm doing it correct. So the two pitchers can hold x plus y, right? The two pitchers can hold x plus y. So, and we're talking about pints, so then it's 2 times x plus y. Man, this was difficult. All right, but we got it. And I will figure it out. So let's go on to the next page. All right, so I'm gonna zoom out and we are gonna be dealing with algebraic equations. We're gonna represent algebraic equations, okay? So let's start with the first problem. A recipe, let me see. You see that? Okay, so I'm gonna enlarge it. Yes, okay, there you go. A recipe calls for 3 times as many blueberries, B, as strawberries, S. Which choice represents this situation? Well, you gotta pause this and you gotta figure out which represents the situation. What do I know? That we need 3 times more blueberries than strawberries. This one says S equals to 3B. This one, if I was to translate it into English, says the strawberries are 3 times the amount of blueberries. But that's not what we want. It says that there are 3 times as many blueberries as strawberries. So B, if I was to write an equation like that, I would say B is 3 times, okay, the blueberries are 3 times more than the strawberries. Okay, and there goes your answer. All right, the next one. Let me see now. Express the total weight P, okay, of a field animal watering pail. If the pail weighs 12 pounds and the water weighs 8.3 pounds per gallon. Let gallons be G, okay, so the total weight is P. So in each case, we're gonna have P equals, and P equals. Now, it says that the pail, okay, the pail weighs 12 pounds. Okay, so that's it. And the water weighs 8.3 pounds per gallon. Okay, per gallon, right? See, the word per means multiplication. So it's going to be 8.3 per gallon. Gallon is G, 8.3 G. Ha! I'm nice. 8.3 G. So it's going to be something like 8.3 G plus the 12 pounds that the pail weighs. Okay, so then which one is the answer? This equation right here. All right, next one. Okay, so here it says Carl is thinking of a number. He states that twice the number decreased by 6. Twice the number decreased by 6. Okay, so I got the first part. Is, the word is means equal, 24. So that's what I get. I'm not sure if that's going to be the answer, but let's see now. Which choice can be used to find Carl's number? Yes, you're right. The last one, right here. Not bad. Okay, let's continue with this. Oh my God, this one is hard. Hopefully you could see this. Now, come on. Okay, there you go. It says a formula defines a value v to be 1/2 of the sum of 3 consecutive integers. Which choice represents this situation? All right, so in all choices we see 0.5, 0.5, 0.5, 0.5. That represents the 1/2. Now, consecutive numbers. What in the world are consecutive numbers? Well, you know what? Get ready because you're gonna have to take notes. I'm gonna explain to you what consecutive numbers are. So let's see now. Let me get a page. I'm just gonna get any random page. There you go. Okay, so take notes on this because it's gonna be very important. Consecutive numbers. This is your lesson in consecutive numbers. Consecutive numbers. Consecutive means one after the other. So for example, if we know the values, and let's say we start at 1, then the next number is 2, the next number is 3, the next number is 4, the next number is 5. So this is for consecutive numbers. Then we have something called consecutive even numbers or consecutive even integers. So how is that possible? Well, let's see. Consecutive even consecutive even numbers. Okay, what are even numbers? Numbers that can be divisible by 2. For example, 2, 4, 6, 8, 10, so on and so forth, 12, 14, and so on and so forth. Okay. Then we have the consecutive odd integers. Consecutive odd numbers. Consecutive odd numbers. What are those? Well, odd numbers start at 1. In other words, odd numbers are numbers that are not even. So after 1, we're not going to put 2. We're going to put 3, then 5, then 7, 9, 11, 13, and so on and so forth, 14. All the way to infinity.
1?
No, not 14.
3,
13.
5, 7, 9.
Okay, so now, let's say you don't know the numbers. So then I'm going to give you the greatest advice of your life. When you don't know your numbers, your first number is going to be x. Consecutive, your first number is still going to be x. Can you stop doing that? Thank you. Consecutive odd numbers, your first number is always going to be x. X or a or n or whatever. It really doesn't matter. Now the difference is the following. Consecutive numbers, as you can see, what is the gap or the difference between the first consecutive number and the second consecutive number? Okay, how many numbers do I have to go to get from 1 to 2? How many numbers do I have to go to get from 1 to the number 2? One number, right? What about from 2 to 3?
2 to 3 is 1.
1. From 3 to 4?
1.
From 4 to 5?
1.
Okay then. So your first number, let's say your first number is x. Then your second number is going to be x plus 1 because they go by ones. Then once you have that, your next number is going to be x plus 2.
X plus 1 is
X
2x.
plus 3. X plus 4.
X plus
Okay,
3.
that's how you do it. That's how you do it. So those are consecutive numbers. They go by 1. Remember, give a value for x. Let's say x is 1. So then this one is 1 plus 1 is 2. This one is 1 plus 2, 3. 1 plus 3, 4. 1 plus 4, 5. That's how it goes. Okay then. Now let us go with the consecutive numbers. Okay, let's go with the consecutive even numbers, sorry. Okay, so the first number is x. Let's say x is the number 2. So then how do I go from 2 to 4? How many numbers do I have to go?
2.
2. So then the next one will be x plus 2. Then x plus 4. Then x plus 6, right? Then x plus 8 and so on and so forth. Okay, now remember, these expressions represent consecutive even numbers because they go by 2s. So something funny is going to happen right now. Let's go with the consecutive odd. The first consecutive odd number is going to be x or n or whatever. So if let's say x is 1, then how do you go from 1 to 3? How many numbers you have to skip?
1 to 3, that'll be 2.
2 numbers, okay. And then if you want to go to the next one, it's going to be, because they go by 2, so it's going to be x plus 2, x plus 4, x plus 6. And then you're going to be asking me the question, wait, hold on a second, you made a mistake. Consecutive even, I represent like this. And consecutive odd, I also represent the same way. Yes, because x is the variable that's going to take on an even number. X is the variable that's going to take on an odd number. But then again, look, even numbers, they go by 2s. Guess what? And odd numbers, they also go by 2s. So it's the gap that we're representing over here. Is the gap. Okay? Don't think for a second that this is even and that's why this is an even number. Look, 1, right? 1 plus 2, 3. 1 plus 4, 5. 1 plus 6, 7. So they are odd numbers. Okay? Cool? Okay, I hope you took notes because this is very important. Okay? And if you still have questions, you can ask me. All right. Now let's move on to the problema. So it says that the formula defines a value v to be 1/2 of the sum of 3 consecutive integers. All right. So, is this the sum of 3 consecutive integers? No, right? Is this the sum of 3 consecutive integers? No, based on what we just seen. Okay. Is this the sum of 3 consecutive integers? X plus 1, x plus... Yes, so then this could be one of our answers. Let's take a look at the other one. Is this the sum of 3 consecutive integers? Or is this the sum of 3 consecutive even or odd integers? Right. This is either even or odd depending on what value you give for x. So now, this is the sum of 3 consecutive integers, and this is nothing more than half. So this is half of the sum of 3 consecutive integers. See? Wasn't that bad. Let's move on. Okay, here we go. So it says, the bulb on the bay, okay, the bulbs on the bay holiday drive-through attraction charges $12 per car. Per car. There's going to be a variable right here because it says per car. Plus $1 for every individual. Okay, and individuals is represented by the letter P. So you need to highlight the important information. RTFQ. Read the full question. In the car, Which choice represents the total cost per car? Let's see. It charges $12 per car. Okay. Charges $12 per car plus $1 for every individual P. Oh, okay. The individual is P. Okay. So $1 for every individual P in the car. Which choice represents the total cost per car? Per car. So, in other words, each car. So, one car. Okay. So, individuals in the car would be whatever, 5, 7, I don't know how many you can fit in the car. And you're gonna charge. So, basically, if there are 5 individuals, no, if there's only one individual in the car, they're gonna charge you $12 for the car. Okay, they're gonna charge you $12 for the car plus how many individuals you have. So you could have 1 individual, 2 individuals, 3 individuals. Wait, so you could have different variations of individuals in the car, different amounts of individuals in the car. So that right there has to be a variable. So thus making my answer 12 plus P, or P plus 12. Okay, now why isn't this the right answer? Well, these are individuals. So 12 times 1 is 12. I mean, like, you have one individual, and all of a sudden you're gonna multiply by 12 and you're gonna have 12 individuals. Doesn't make any sense. See that? Same thing goes here. Here you're gonna have, if you use the distributive property, okay, you're gonna have 12P, and you're not having 12P. You just have a number of individuals that could range from 5 to like 7, I'm assuming. So no, same thing here. 12P. 12P is not how you represent the individuals. Okay, so that's it. So that's why choice number 1 is your right choice. Okay. Let's see now. A cell phone company charges $65 for the phone and $24 a month for the service. Okay, so here we go. We're gonna have $24 a month for the service. And the $65 is for the phone, so it's a one-time thing. Which choice represents the cost? Okay, so cost. So you see the choices: C equals, C equals, C equals, C equals. Okay, so which choice represents the cost C of the phone for the first M months? Well, $24 per month plus the $65 for the phone. So then, in this one, okay, let me make it larger. Okay, in this one, I have $24 per month. Like in 2 months, it's $48. But you're subtracting the price of the phone. No way. This one, I don't know where the 89 comes from. Oh yeah, they added 65 and 24. That's weird. So no. 24 months divided by 12. This is $24 a month plus the $65, and you're gonna divide that by 12. I don't understand why you're gonna divide that by 12 if you're getting charged monthly. $24 a month plus the $65 of the phone, and you have found your answer. Nice, beautiful. You did awesome. So once again, here is dividing, so I don't understand why you're dividing if you're actually gonna be charging more, not less. Okay, so now let's see. At the mall, a soda costs $1.95. A burger costs $3.20. B, okay, so it's giving us the variables: soda S, burger B, and chips C. So $2.10 for the chips. Gelato. Oops, sorry. Okay. Gelato is an Italian form of ice cream. A gelato booth sells small gelato cones for $2.95 each. And look, gelato is going to be represented by the letter G. So Carlos buys a burger, soda, and chips for himself and each of his friends. Which choice represents his total cost without the tax? Okay, look, I'm going to tell you why this is wrong and why this is wrong. Whoop, I'm going to have to say it. Okay, and why this one is also wrong. Carlos is gonna buy soda and chips and burgers for himself and his friends. So if he buys, if he has two friends, how many meals is he gonna buy? 2 or 3? Correct. He's gonna buy 3 meals because he's gonna buy for his friends and himself. That's why we have the +1 in here. All right. Now the thing is that he's gonna buy it for everybody, but I don't see his friends and him being included here. I only see him buying the burger, the soda, and the chips. Let's try the other one. Here in this expression, or actually in this equation, you see that we have the expression that represents himself and his friends. And the whole thing is going to get a burger, a soda, and the chips. So therefore, this is your right answer. If you still have any questions, you could write or you could actually ask me, okay? Alright, so 2 of his friends, right here. Alright, right here. So 2 of Carlos' friends do not want chips. Which choice will amend the answer to part A to reflect this change in the total cost? Well, let's see. 2 of his friends don't want chips. So let's talk about this again. Can this be the right answer? This cannot be the right answer because he's only talking about the friends. But remember that he's buying soda for himself. So this cannot be. Plus, I don't understand. Burger plus soda plus chips -2. -2 what? It doesn't say anything. Alright. Now let's try the next one. Alright, let me see now. A little bigger, a little bigger. Okay, there you go. So, yes, he's including his friends here. And he's going to get a burger, a soda, and he is not going to get 2 of the chips. I don't understand. He's buying burger, soda, but he's not getting chips at all. He's subtracting chips without getting chips. What's wrong with this guy? Then let's try the next choice. Okay, we spoke about it. It says he's gonna buy for himself and his friends. So this cannot be the right answer. Now here, that's the right answer, Becker. Yes, I know, but look. He's gonna buy a burger, a soda, and chips for him and his friends. Then from whatever he gets, 2 of his friends don't want chips. Okay, fine. Then subtract the 2 bags of chips that his friends don't want. And we're Gucci with that. You understand that? If he has 7 friends, then you buy the 7, and then you take away 2 bags of chips. That means that 3 of his friends, let me see. Did I say 7? Well, if he has 7 friends, then all 7, he buys all 7, but then he subtracts 2. So therefore, only 5 of his friends are going to get the whole thing, and 2 of his friends just get the burger and the soda. See that? Okay, cool then. Oh, yeah. All right. Okay, here we go. Carlos' friend Amanda says that she will pay for herself and each of the friends to have a gelato cone. You know what? Make this smaller. Okay. So she will pay for herself and each of her friends to have a gelato cone. Then it says 3 of the friends do not want a cone. Okay. Which choice represents Amanda's total charge? CH. Okay, so that's what she's gonna pay without tax. Well, let's see. She's gonna pay for each of her friends and herself, right? So we have gelato for a friend minus 2. Let's see now. A gelato for a friend. Oh, wait. A gelato for herself. But then G times negative 2. Okay, so if I get that, I get GF minus 2G. Okay. Now, what is this? Friend plus 1. Let me make this a little larger so we could see. So this is a friend, okay, F plus 1. Times G minus 3. I'm not sure what that means. Let me see. Carlos' friend Amanda said that she would pay for herself and each of the friends to have a gelato cone. Okay. 3 of the friends do not want a cone. Which choice represents Amanda's total charge? Well, she's only buying the gelato, right? For herself and the friends, but 3 don't want. 3 friends don't want. Wow, this is complicated now. I'm not sure. So let's see now. My God, I'm going crazy with this. So she, okay, Amanda's friend. Now 3 of her friends do not want a cone. 3 of the friends don't want a cone. Oh my God, I just hit rock bottom. So this is gelato for a friend minus 2 gelatos. Carlos' friend says she will pay for herself and have a gelato cone. Okay. Three of the friends do not want a cone. Wow. I don't know, but all right, so I'm gonna go with choice number. Oh my God, let me see. 3 of her friends said that they don't want gelato. So what is her total charge? Wait, they're gonna charge her gelato for a friend minus 3 gelatos. I am gonna go with this choice. Definitely, I'm not so clear on this one, but definitely I think, I mean, she has gelato for the friends minus 3 gelatos, right? And here it was gelato for the friends minus 2 gelatos. So I'm gonna go with this answer. Okay, so let's see now. Oh wow, quiz number 11. Let's see what it says. Okay, the value of x squared minus 9, okay, is a real and irrational number when x equals 2. Okay, so real and irrational when x equals 2. So let's see now. 5 squared minus 9. 5 squared is 25. 25 minus 9 is 16. No. 0. 0 squared is 0 minus 9. 0 squared minus 9. That's going to give you an error. Negative 3 squared is 9 minus 9 is 0. So, okay. And 4 squared is 16 minus 9. Okay, what is 16 minus 9? That's 7, right? Okay, so 7. Is 7 a perfect square? Is 7 rational or irrational? Irrational, right? Good. So we just answered the first question. Now, how would you justify this? Well, if we try each of the choices, okay, based on the following mathematical evidence, we see that when 5 is squared, we get 25. 25 minus 9 is 16, and the square root of 16 is 4. So therefore, that is rational. And then we move on to the next one, and we see that when we put it on the calculator or when we do it, we cannot take the square root of a negative number. So therefore, that is an error and is not rational nor irrational. No, it's not rational nor irrational. And then we try the other ones, and of course, and that's how you justify your response. Okay. Which number below is irrational? Why is the number you chose an irrational number? Okay, which number below is irrational? 4 over 9, if you take the square root, is the same thing as saying the square root of 4 over the square root of 9. So this can be turned into a fraction. If you don't understand, I'm going to do it right here. That's what it means. The square root of 4 is 2, the square root of 9 is 3, and 2 over 3 is rational because it's a fraction. The square root of 121 is 11. So therefore, that is also rational. Then you have the beautiful number radical 20. Radical 20 is irrational because it's not, okay, the radical 20 is irrational because it does not belong to the group of perfect squares, meaning that when we input it on the calculator or in the calculator, and when we input it in the calculator, we get a bunch of different numbers, which in the calculator different numbers, which is the way the calculator represents irrational numbers. You write that down. I'm writing in ink so you can see better, but my handwriting is not that good either. Okay. Okay. Given blah 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 blah, identify the expression that is a rational number and explain why is it rational. All right. So which of this expression is rational and why? So let's zoom in so you can see better. Definitely, this is an irrational number. So that makes the whole thing irrational. So this is irrational. 164 is irrational. It does not belong. If you take the square root of 164, you're going to see that the calculator is going to give you a bunch of numbers. Now, the square root of 196 is 14. Okay? So, the expression that this is what you're going to be writing. Okay? I'm not going to write it. You write it. The expression that I identified as a rational number is radical 196. That's what you write the whole thing, okay? The expression that I identify as a rational number is radical 196 because the square root of 196 is 14, right? I'm not writing the whole thing, I'm just giving you like reminders. So the square root of 196 is 14, and 14 can be rewritten as 14 over 1. Therefore, 14 is rational. Or you could say, based on the following mathematical evidence, we can say that the radical 196 is rational because, and then you say the square root of 196 is 14. 14 can be the same thing. Okay, write an irrational number and explain why is it irrational. That's crazy. I'm not gonna do that because if I do it, okay, I'll give you irrational numbers. Pi, e, radical 2, radical 3, radical 5, radical 6. But then you have to explain why is it irrational. Remember what an irrational number is? A number that does not end nor repeat. And usually we're talking about a decimal, right? All right, cool. Now, did I finish with that quiz? No more questions? Okay, we're done with this packet. Thank you very much. Now to upload it onto YouTube.